It is the last day of ellipses. It's day 2. We're only spending 2 days on it. We're just going to jump right into it because you have the handout. If you don't have the handout, you can download it and make sure it's on there. Okay, here we go. Here we go. We're going to start off with graphing and labeling the following. So we're going to have x minus 2 squared divided by 25 plus y minus 3 squared divided by 9 is equal to 1. All right, let's start off right off here. What do we? You have got it absolutely correct. Yeah. All that's changed is that the center is no longer at 0, 0. The center is at h comma k. So in this case, the center is at, I'll write down, the center is at 2 comma 3. That represents your h, and that represents your k. So everything else is the same, except the center is somewhere else. All right, let's take a few minutes and write down all the things that we know about this particular ellipse. First of all, is it a left-right or an up-down? This is a left-right. Yes. How can you tell? Yes, because the bigger of the two numbers is 25, and that happens to be underneath the x, and x's run left and right. So the major axis is along the x, parallel to the x-axis now. Good. What else do we know? We know that a squared has to be a value of? A squared is 25. That means a is plus or minus 5. We know b squared is a value of 9. So b must be plus or minus 3. And lastly, we know c squared has to be a squared minus b squared. There's the relationship between a, b, and c, right? So therefore, c squared has to be 16 if I take 25 and subtract 9. So c squared is 16, which implies c is plus or minus 4. That's all the information that we have, right? We know everything we could possibly want to know about this ellipse. Now all that's left to do is graph and label. So I'm going to move this down and give myself some graph paper here. And let's put it on there. So I'm going to go 2 units to make it, scalable here, because my graph paper is... Oh, wait a minute. Can I do this? Such a dork. I love it. All right, now it's easier for me. Perfect. Why didn't I think of this before? Gosh. Wish we all had tablets. One day, you guys, we will all have tablets, and we can just take our notes, and it'll be good to go. Okay, center is at 2 comma 3. So go over 2, go up 3. Ooh, I'm going to run into some trouble here, I can tell already. Yep. I can fix that too. Sorry for taking up all your time here. Check this cool trick out. See what I mean? Whoa. Bye-bye. I know. One day we'll all have it. We'll all have it. Okay. All right, good. So there's my center. What else do I know? Let's make my center. There it is. I'll make it bigger. It's close. That's all I got. I know it's left and right, so I know that the major axis, sorry, a little distraction there. The major axis has to go this way, okay? I also know that A is 5 units, so I need to go plus and minus 5 units from the center. So I'm going to go over 1, 2, 3, 4, and then 5, so to this point. So that has to be a vertex. And I'm going to go back 5 units, 1, 2, 3, 4, and 5. That's the other vertex. Let's go ahead and label those vertices, okay? This is the point 7 comma 3, and this is the point, looks like negative 3 comma 3, is that right? Okay, cool. That takes care of the A part. Let's do the B part. That means I go up and down 3 units. So I'm going to go up from the center, 1, 2, 3. Down from the center, 1, 2, and 3. And let's label those coordinates. That looks like 2 comma 6, is that right? And then 2 comma 0. Perfect. Last, let's label our focal points, which are plus or minus 4 to the right and left of the center. So I'll go 1, 2, 3, 4. So this point here is a focal point, and that is at the point 6 comma 3. And then let's go 4 back, 1, 2, 3, 4. Another focal point, which is negative 2 comma 3. Now you have all the information that you need to make a sketch, which I think is the most difficult part of the whole day. Look at that. I can't even hit that thing. Terrible. Oh my gosh. It's the worst. That's the worst ellipse I've ever drawn. Let's try that again. Okay, you ready, guys? You guys ready to go? Here we go. Let's graph and label this horrendous looking thing. 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. All right. This thing looks nasty, right? So the question I have on the left-hand side for you is, how do we get this into standard form? Yes, what do you think we do? We complete the square on which one? You got it. Complete the square on both, that's the key, x and y terms, because both of them are squared. There is a warning involved with this, and we're going to come up to that in just a second. So here's what we have to do. Let's gather our x terms. So I'm going to have 4x squared minus 8x plus y squared plus 4y, and I'm going to take my constant term and move it to the other side of the equation. That gives me negative 4 on the other side. You guys with me? Okay, next, let's group the x terms together, here, and let's group the y terms together right there. So what we're going to do is simultaneously complete the square on both x and y at the same time. But in order to complete the square, what does the coefficient of the squared term have to be? It needs to be a 1. So we need to do what to that 4? We need to factor it out. You guys got it totally right. So if I factor out a 4, here's what I'm left with. I have x squared minus 2x plus the magic number. I'm setting that part up to complete the square on the x term. Let's do the same thing on the y term. In this case, there's a 1. No, because I only factored a 4 out of the first binomial. So then I'm going to have y squared plus 4y plus the second magic number equals, on the other side, I have negative 4 plus the first magic number plus the second magic number. That's the setup. Lots going on there, but it's actually really clean. Okay? All right, someone tell me, what is the first magic number on the x term that completes that square? 1. Yeah, half of negative 2 is negative 1, squared is 1. Okay, the warning is this. What number goes on the other side? 1. No, not 1. That's the warning. Huh? Olivia, say it. Can you tell me why? That's exactly right. We are not actually adding 1 to the left side, are we? We're adding a multiple of 4 times 1, and that's what goes in that box over there. You guys got it? That is the most common mistake made by everybody that does these problems. They forget to multiply by the constant on the outside term. Okay? So we're all set up for the y term. What's half of 4? 2 squared, so 4 there. And I can safely put a 4 over there because I have a 1 outside in front of the number there. You still with me? Okay, cool. Let's see here. This is going to become, back to red, this is going to give me 4 times x minus 1 squared plus y plus 2 squared. On the right-hand side, notice that these cancel out, leaving me with 4. We're almost there. What's my next step going to be? Divide by 4. You got it. Divide by 4, divide by 4, divide by 4. So something nice happens for us over here. So my equation looks something like this. X minus 1 squared over 1 plus y plus 2 squared over 4 is equal to 1. Now I'm in business, aren't I? Now I have something that I can work with. You guys with me? Okay, let's figure out all the pieces that we need here. Is this an up-down or a left-right? This is a left-right. Oh, man. I even wrote in cursive. It's an up-down. That's all right. Wow, that's pretty good, huh? Okay, this is an up-down because the 4 is squared, the 4 is underneath the y. What's the value of a squared? No. A squared is 4, so a is plus or minus 2. This is a tiny. No. What's b squared? 1, so that means b is plus or minus 1. And then c squared is the difference of the squared, so that's going to be 3. So c is plus or minus the square root of 3. We're going to use that in a second. All right, hang in there. Hang in there with me. All right, we need to put all this stuff onto a graph. This is a tiny ellipse, so I don't have to go too crazy with it. All right. Here's x, here's y. Oh, where's my center, by the way? I didn't get that either. 1 comma negative 2. Nice job, everybody. Okay, here we go. Center over 1 down 2. Perfect. There's my center. We know it's an up-down, so I'm going to draw the major axis right here because it goes through the center. How far up and down do I go? I go 2 units, don't I? Yeah. I go 2 up. There's a vertex, which is the point 1, 0, and 2 down. There's the vertex, which is 1, negative 5. 1, 2, 3, 4. Left and right, how far do I go? 1 unit. Now it's from the center, right? So go left 1 and right 1. I said that backwards. That's okay. And then that's enough information to actually draw the ellipse. Hey, that's not bad. The only other thing I need to put onto my graph are the focal points, and it's a very strange way that they tell you in the book. Because this is not a nice little easy pretty number, here's how they represent it, and see if you can catch on. One focal point is, okay, which will be somewhere over here, I go over 1 unit, comma, I go down 2 units, and then I go how far past? Did I lose you there? Okay. Oh, go away. No, no. What is the definition? So from center to vertex is A. What's center to focus? And what is C? So here's the point. I go over 1, comma, down 2. How much more do I go? There you go. 2 minus the square root of 3. That is this focal point over here. That's how they represent. That's the exact location. Yeah. Now, to get the other one, this should have been a negative 2, so we didn't say that in the video. So we're going to go over 1. Yes, so we're going to go over 1. The other focal point is over 1. Down how many? Negative 2. And then we back up how much? There you go. Now, the book in the back will combine these two to make it look like this. 1, negative 2 plus or minus the square root of 3. Now, if I didn't tell you that, you would not know what the heck was going on back there. All right? You can write it like that. You can do the cool plus or minus thing. You guys got it? Okay. The idea of eccentricity is the ovalness of the ellipse, okay? You know, some ellipses are like really, really long and skinny. And then some ellipses are almost circle. So the range in between there is called eccentricity. We can talk about the eccentricity of an ellipse. So it turns out the eccentricity is nothing more than an inequality. Okay? So it's somewhere between 0, less than or equal to, well, we have eccentricity is just this, E. And the definition of eccentricity is nothing more than C, the distance from the center to a focus, divided by A, which is the distance from the center to a vertex. And that has to be less than 1. So it's somewhere between 0 and 1. And it turns out, it's so nice, the closer you are to 0, the more circle-like you are, which is nice and convenient for us because O looks like a circle. It can be. Yeah. So the when it was a circle, that's what I'm saying. So when the eccentricity is 0, you actually have a circle, right? And then when the eccentricity is closer to 1, you have more severe ovalness. So if it was 1, would it be a line? Say it's spelled severe, S-E-V-E-R-E. Severe ovalness. If it was 1, would it be a line? Yes, that's exactly right. If it was 1, you'd get a line. So it can't be 1 because then you have something other than that, okay? So you have the eccentricity. The closer you are to 0, the more circle-like you are, and the closer you are to 1, the more oval-like you are. The more extreme ovalness you have. Does that make sense to you?